Dear student, we are on the CEC Gurukul lectures and we are in the series of the experimental physics, and today's topic is the to find out the characteristics of the solar cell. So here we are discussing the working principle of a solar cell. Solar cell which converts the solar energy into the electrical energy. How it converts the solar energy into the electric energy? Here on the screen we are having the working principle of the solar cell. Now here this is the solar panel which is made of the N and P type of junction, and here we see on the screen that there is a N type and the P type silicon are connected to each other, and in between that there is a depletion layer where we have the combination of the electron and holes pair. Now see that the light from the sun fall upon this panel, and that is connected with the output which is in the form of the bulb. As the light fall upon this panel and the bulb will illuminate it, it means the sunlight is converted into the electrical energy, and then we can get the good output if all the solar panels are connected to each other in a panel. Solar cells are connected into a panel, and large number of the solar cells are on the panel that give the maximum output. So this is the basic principle of the solar cell experiment. So light from the sun fall upon a panel, then we can get the output. It means the sun energy converted into the light energy. Now here we see the experimental setup we use in the laboratories. The bench where the solar panel is mounted, and the lamp on the left hand side we are having the solar lamp. This is the simple lamp bulb which from which we can get the photons which fall upon a panel, and there is a kit where we can get the current and voltage output with the load with the changing of the load. So this is a basic experimental setup which we use in the laboratory. Now as we discussed earlier that there are the many aim of this experiment. One by one we will discuss. First is to determine the illumination characteristics. What is this illumination characteristics of a solar cell? That which give the output. It is seen that the current through the solar cell increases as the intensity of the light falling on the solar cell increases. As the light fall upon a solar cell increases, the current increases as defined in the graph. Current versus intensity, lamp voltage. So intensity increases though current increases. Now what is the procedure to get the illumination characteristics? First we make the circuit, we connect the circuit. A 100-watt bulb is arranged over the solar cell such that the light fall on it at the normal. From the solar cell for which we are using the lamp to fall the light, and the light fall at a normal. The intensity control is kept, and which is minimum at the rate of the 50 volts, and the lamp is switched on. As the lamp is switched on, we adjust the resistance box at 0 ohm. First the resistance will be 0. Both the knobs which is across the 110 and 100 ohm will be at the 0 offset positions we are having, and we will note the short circuit current that will be the maximum. Then we just write it on the table. Then we increase the intensity of the lamp in the stepwise 100, 150 and 200 volts, and note the corresponding current for the each setting of the voltage, and then we record the reading in the table. This is the table which is the intensity versus current, and then we record the reading. And here we see in the upper diagram, this is a circuit diagram where PN junction connected with the voltage in the parallel, then it is arranged, and this voltage is connected parallel with the resistance box, and ammeter connected. Here we see that the PN junction, the panel, the solar panel negative terminal is connected with the negative terminal of the voltage, and in this voltage is connected with the load resistance which is also parallel to this, and ammeter is connected in between that. So in this table we can take the readings, intensity versus current. the intensity is taken as proportional to the current, the voltage given to the lamp. Then we plot a graph between the current and the intensity. That graph is the straight line. Here we see this is the current versus voltage graph that we define. The next experiment is current voltage characteristic. This is a very important aim. The output characteristics, current voltage characteristics, we can find out by first we can get the open circuit current. The output voltage of the cell is 0.6 volt and the current is 0 and the panel is short circuit. The current is maximum while the output voltage of the cell becomes 0. And in this case, both the cases, the output power is 0. Here the two conditions we have: first the voltage is 0, current is 0, then voltage is 0, then power will be 0, as this is the cross product of the voltage and the current. So when the voltage is maximum, the current is 0. When the current is maximum, then voltage is 0. It is seen from the curve that the voltage varies depending on the current drawn. So what is the procedure to get the current voltage characteristics? The intensity of the lamp is kept at minimum value in the first step. That will be the 100 volt. Disconnect the load resistance. We are not applying any load to any voltage to the circuit. So then we can note the open circuit voltage. Then adjust the resistance box at the 0 ohm. Both the knob must be at the 0. It may be of the cross 10 or cross 100 and it must be the 0, and we note the short circuit current. That will be the maximum value of the current. we can find out. Then now next step, we set a load, we increase the load approximately 100 ohms. Now note the corresponding voltage and the current. Make the table as shown in the table, as we will show the table. Then we have a table in which one column is the voltage and another is the current and one is the load. Then if we increase the load, then we note the corresponding value of the voltage and the current, and it vary the load in step of the 1100 ohms, and note the corresponding voltage and current of the each setting of the load in the table. Now intensity of the lamp is increased to say 150 volt. In the next step, intensity will change. In the first step, fix the intensity. In the next step, we change the intensity. Intensity of the lamp is now increased 150 volt. In the previous we have the 50 volt. Now here 150 volt. The load again varies from the 100 to 1100 ohms. Now again we can note the corresponding value of the current and voltage for that particular change of the load. The open circuit voltage and the short circuit voltage is also noted to determine the maximum power. Now the intensity of the lamp is set at 500 volt, and this from the 150 volt the intensity will change 200 volt, and we will repeat it, means we just change the load and we will calculate the current and voltage, and this we will record this in the table. Then we plot a graph between the current versus voltage. Here we see on the screen, this is the output. This is the output. This table we will make. Here we just take the intensity. For the one intensity, we note down the voltage and current for a particular load. The second intensity, represent the intensity I2. Intensity will change. Voltage and current we will note. Here see in the table, voltage in the volt and the current is in the milliampere, and the load will change in the 100 ohms, 200 ohms, 300 ohms, and so on. So at the three value of the intensity, we are having the different values of the voltage and current, and at the different value of the load. Now we see that this is the output we will get, and this is the circuit diagram where we connected to get the VI characteristics. Now here see right hand side, this is a PN. This is a PN junction, the PN solar panel. The negative terminal connected with the voltage negative. Then load resistance is also connected, and this will change according to the 100, 200 and 300. Now the output we see on the right hand side, that is the current versus voltage graph. There we see the curve type of the graph we will get. First the saturated value we will get at a particular point. If we change the voltage, the current will be the same, and after increasing the voltage, after increase the load, the voltage will the current will decrease. After changing the voltage at a particular voltage value, the current will be the same. After that, as we increase the voltage, the current will try to decrease. Now this is the basic diagram where we can, on the screen we are having the IV curve, which represent the area under the curve, means it is representing the maximum area covered by the panel, by the illumination of the light. So here this is the output we will get in the IV characteristics. So this is the table as already discussed. Now next aim is the power load characteristics. How we will get the power load characteristics? By using the solar panel. To drive the maximum power from the panel, an appropriate load is to connect it across it, means resistance we will change so that the voltage will change and the current will be, we will get the value of the load that allows the cell to give the maximum output power is obtained by drawing the power load characteristics, where we are seeing that the load other than the maximum will produce the less power. Now on the screen here we see that load RL as increases, the power will increases, but at a particular point when the load increases, the power will decrease. At a particular point we have a maximum power, as we see in the graph. So first, as the load increases, power will increases. At a maximum value of the power, at a particular value of the load, maximum power we will get. Again the load will increase, the power will decrease. Now what is the procedure to get the power load? First is using the set of the reading obtained from in the table as we are having, then calculate the output power of the cell, make the table by recording the reading, then we just plot a graph. Then what reading we will note? We note the value of the power as well as load. As the load changes, then we can note the I and V, and in this manner we can get the output power. Here we see the intensity I change at 100 volt to 150 to 200 volt, then the power for a load 100 ohm, 200 ohm and so on. Then we plot a graph, then we get then we can get a curve on that. Now what is the area characteristics? The power delivered is proportional to the surface area of the solar panel and exposes to the light. Then how much power we are getting, how much solar panel are exposed through the solar light, that is governed by the relationship P is equal to Ka, where P is the total power available and A is the area of the cell, K is the proportionality constant. So P directly proportional to the A. So P is equal to Ka, define the area power output. So the area characteristics, how we will get? What is the procedure? First step, set the intensity of the lamp at the convenient level. At a particular, we can say 200 volt is better to get the area characteristics. Adjust the load at the optimal value. Then we place a chopper plate having the different slot areas in front of the solar cell in the groove provided. Then adjust the one of the slots, say 16 over the solar cell, which reduce the area which is illuminated. The voltage and the current reading will be noted in the table. So area characteristic, adjust the other slots, say 36, 64, this is the area in the millimeter square over the solar cell, and note the corresponding current and voltage for each slot of area and record the reading in the table. Here we are here what we are doing, here we select a particular area and then at that particular area we are calculating the corresponding current of that area by changing the load. So in the table what we are having the slot area which is in the millimeter square, then what is the voltage corresponding to that area, and what is the current and what is the power in that particular area, so that we can get the aerial characteristics of the solar panel. So now if we graph between the power versus the area, then we are having a straight line. The power will increase as the area of the exposure through the sunlight will increase. So this is the graph between the power and the area. The next and the last characteristics, last aim to determine the spectral characteristics which give the response of the solar cell to the light depends upon the wavelength of the incident light. How much light is falling upon a panel, that represent the spectral output. In the sunlight, different colors have different intensities, that will give the output. The variation of the power of the wavelength is shown in a figure. Here you see, as the wavelength changes, the power will change. How the power is changed as the wavelength changes. Now what is the procedure to get the spectral characteristics? Again we set the intensity at a particular value, that is 200 volt, then we adjust the load at the optimal value, then we put the different color filters. If we use the sunlight, then no need to put the filters, but if we are using the lamp, then of a different value, different color filter we will put over the solar cell. For each filter we note the voltage and the current, and we will record the reading in the table. The wavelength corresponding to the each color is noted and calculate the output power. So we plot the graph between the power and wavelength as we have seen. Now this is the table which we require just to get the reading. First the filter color, what color? Green, red, yellow, blue, that we write on this side, the filter color. Then the peak wavelength which is in Armstrong terminated, then the voltage and current we will measure. By multiplying voltage and current we can get the power. Now these are the optional aim, that is the distance versus open circuit voltage. Previously we have done, we recorded the current voltage characteristics. The same process we will follow here, but here we vary the distance between the source and the photo cell. We will change the position of the solar cell which is illuminated. We change the position of the bulb and the photo cell so that the distance can be vary. At the different distances we can take the output of the open circuit voltage. So at a various position like 15, 18, 21 centimeters, so on, we can get the various output. Next, distance versus short circuit. Again we repeat the same process as we have done in the current voltage characteristics. We vary the distance between the source and the photo cell, then we note the short circuit current for each position of the cell source. The same centimeters we are having 15, 18, 21 and 24, so on. Experimental measurement of the short circuit current we will take. Then we make a circuit using the R2 and multimeter. Set the lamp voltage at 100 volt. Then adjust the supply voltage at 1.5 voltage. Then vary the R2 means low resistance, till the voltmeter we record it to the 0 voltage. In this position, the cell and the battery try to send the current through the resistance box, and when both the current are equal, no current will pass through it. So the resistance box does no voltage drop across as it measures by the voltmeter. In this case, current obtained through the multimeter gives the short circuit current, and we repeat this experiment for the different voltage, and the corresponding we can find out the current. And in this manner we can get the table in which we are having the lamp voltage, experimental value of the short circuit current, and this is the theoretical value of the short circuit current output, that we can VI value. From the VI, what is the precautions we have to follow to perform this experiment? Number 1, the solar cell should be exposed to the sunlight before using it in the experiment, or the light which are using in the laboratory should fall normally on the cell. The resistance in the cell circuit should be introduced so that the current does not exceed the safe operating limit. Moreover, the cell panel should be connected in a parallel or series manner. No discontinuity in the mesh type of photocells, and on the panel they must be connected clearly so that the output can be get. And these are the Viva question we can ask anyone can be asked after performing this experiment. Then what is the difference between the solar cell and the photodiode? What are the type of the semiconductor material used in the solar cell? What is the dark current? What is the difference between the solar photovoltaic and solar hot water system? What is the response time of the solar cell? Some of other questions are, what is the difference between the solar cell and the photodiode? If we take the photodiode is like a solar cell and is a photovoltaic semiconductor devices, and solar cell, photovoltaic cell and the solar cell difference is that in the solar cell we use the sunlight, and the photovoltaic we use the lamp. And the photovoltaic and both are made of the semiconductors. Photodiode, however, are optimized for the light detection, while solar cell are optimized for the energy conversion efficiency. So this is the answer of the question. Now photodiodes are essentially identical to the diode since both consist of p-n junction. The difference is that the diode p-n junction is usually covered in opaque packing, and the photodiode p-n junction is exposed to the light through the transparent packing. And in this way, the photon hitting the p-n junctions can simulate a photovoltaic effect in the photodiode and changes electrical behavior. Next question is, which material is best used in the solar cell? As we discussed that the silicon wafer is used, so amorphous silicon, probably the best developed thin film solar cell technology is the amorphous silicon, which means the silicon isn't arranged into the perfect crystalline structure. And nowadays the research is going on so that the different nanomaterials, the smart materials are used to develop the solar cell so that the efficiency and the fill factor can be increased. Up to now, the approximately efficiency is 30% is increased by using the various composition, doping and the nanomaterials after using the nanomaterials. So what is a dark current? Dark current is a relatively small electric current that flows through the photosensitive devices such as a photomultiplier tube, photodiode or the charge coupled devices when no photons are entering the devices. So this is the definition of the dark current. It is referred as a reverse bias leakage current in non-optical devices and is presented all the diode. And if we talk about the physically, the dark current is due to the random generation of the electron and holes within the depletion layer of the devices that produce the dark current. And there are the many questions. What is the difference between the solar and the photovoltaic? And there is another question, which is the reason what is the response time of the photocell. Response time typically has the range of 5 milliseconds to the 100 milliseconds. The speed of response depends upon the number of the factors including the light level, light history, ambient temperature, atmosphere, material used in the solar cell. That all gives the response time, that all related to the gives times. What are the solar cell? This is the basic question. The solar cell that convert the solar energy into the electrical energy. So this is the solar cell. Thank you very much.